Today we're talking about fractions, and the number on the top is the numerator, the number on the bottom is the denominator. The denominator tells how many makes a complete set. In this particular one, it would take 4 to make a complete set, so 4 would be your denominator. And over here, 8 would be your denominator because it takes 8 to make a complete set. Well, let's pretend that this is a pie, like apple pie, yum. And we're going to cook this apple pie, and let's say we're going to use the number 4 to represent this apple pie because this apple pie is cut into 4 pieces. This one's cut into 8. If I wanted to cook number 4 times a tool, an oven, let's use the 3 oven. Well, 4 times 3 is 12. Oh my. And so instead of having 4 pieces of pie, now I have 12 pieces of pie. Okay, it's cooked, but that's way too much pie. I don't want that much. Let's try a different one. 4 cooked by oven number 2 would give me 8. Well, that's less than that one, but that's still a lot more pieces of pie than I was wanting. Is there a tool out there, an oven, that will cook my number 4 pie and keep it the same number without multiplying it? Because I want pie, but I don't want that much. Well, let's see. You know, I've heard stories of people using a tool called Zero. It was so dangerous, it got so hot that it incinerated the entire pie, and when it was all said and done, there was nothing left. Where's my pie? Be careful with the Zero tool. It could incinerate your whole pie. What tool could it be? How about tool number 1? Ah, there it is. I cooked my pie, but yet stayed the same number of pieces. That's exciting. I can use number 1. In fact, that is the only amazing tool in all the numbers that we have that can do that form right there. It can multiply times what you have and keep it the exact same number. That's amazing. This is like the most amazing tool. So I'm going to use this tool now to do all kinds of things with my fractions. Here, these are whole numbers. Now I'm going to have fun with the number 1 tool with fractions, because you can even take a fraction and multiply it by 1 and it'll still be the same number. That's amazing. What a tool. In fact, this number is so exciting. It's such an amazing tool that you can actually change the settings on it. Well, how in the world do you change the settings on your number 1 tool? Well, let's think about a scenario here. What if I had my apple pie cut into 4s, but my cherry pie is cut into 8s? What if I want my apple pie cut into 8s? How would I use my amazing number 1 tool to change the settings so that I could change these 4s into 8s? Well, first of all, we have to figure out how many times does 4 go into 8? 8 divided by 4 is 2. So we're going to have to set our number 1 tool to the 2 setting. Now here's another amazing thing that this tool does. When you put it on a setting, it takes a number and puts it over itself. No other tool does that. So 2 over 2 would be the setting that the number 1 tool changes to. So I can take it off, I can put this setting, and it'll turn into 2 over 2. When I do that, now I can take my 1/4, which is one of these pieces here. Let's say I marked off this piece. I said, okay, this is the piece I want, but yet I want it in 8ths. So I'm going to take my 2 over 2, which is my setting on my 1. So in other words, you're multiplying it by 1, but instead of using that form of it, you're using the setting of 2. You're setting it to the 2 setting. So 1 times 2 equals 2. 2 times 4 equals 8. There is your eighths. You just now changed your fourth into eighths. Well, what you did is you set it to the 2 setting, so every piece you have is now cut into 2. So that one piece that you had marked off before, which was that fourth of the pie, is now 2 pieces. That's what happened up here. You marked off one piece, but then it ended up being 2 pieces. It's 2/8 is the same thing as 1/4. It's still the same amount of pie. You just sliced it in 2, which is what you did with your number 1 tool. You used your number 1 tool on the 2 setting to change that fourth of a piece into 2/8 of a piece. So now you have 2/8. These are now cut into eighths. They used to be fourths, but we used our tool on the 2 setting to change it to eighths. So let's try that. Let's take a look at how that works. I'm going to let you in on an amazing secret. Are you ready for this? I'm going to reveal some top secret information. A fraction, say like 2/4. This is a fraction. But let me tell you something. It's also wearing a disguise. But I am going to tell you how to remove the disguise. We are going to take that disguise off that fraction and show you what it really is. So watch close what I do. I'm going to tip this fraction over to where it falls down. But I'm going to tip it to the right. You always have to tip it to the right to reveal its true identity. So let's tip it to the right. Okay, I'm pushing it over, going to the right. This number, the numerator, ends up over here on the ground. This line in between the 2 numbers ends up over here and splits in half like that. This number, the denominator, ends up right there. What is that? What? That's a division problem. This is division. 4 dividing into 2. That's what that really is. It's the exact same thing. We pushed it over and the numerator came underneath this little divider line and the denominator stays right there, and now you can work the division problem. That's a little bit advanced for now, but we're just taking that concept to show you an amazing thing about our number 1 tool. Remember, when we had the number 1 tool set on the number 2 setting, it takes the 2 and puts it over itself. What would happen if we pushed that one over? Let's see. We push it over to the right. It always has to go to the right. This one falls down over here. This line falls down and splits in half. The denominator falls down right here. Well, let's actually work this division problem. What is 2 divided by 2? It's 1. 2 divided by 2 is 1. There's our tool. There's our amazing tool. Let's try it on a different setting. Let's try it on the 4 setting. Remember, it always puts the number over itself. We're going to tip it over. Okay? This numerator is going to go here. The line in the middle is going to split in half and go there. And the denominator is going to go there. What is 4 divided by 4? It's 1. There's our tool again. You realize this tool is so amazing that when you turn it into a division problem by setting it to whatever setting you want, it's going to go back to the original 1. That's so cool. All right, let's try some more. Oh my goodness, what if I decided to set it on a really high setting? 15. 15 over 15 is the setting we have now. I push it over and it ends up being the numerator inside the little line, the line split in half, and the denominator right there. 15 goes into 15 one time. Oh my goodness, it even works on the 15 setting. Man, that's so cool. Now that we know that, we can start using it with our fractions. Let's try it. That's so cool. Number 1 is the most amazing number. Now wait. Let's see. Can we do it with number 3? Let's try it. In order to change the settings on number 3, you would have to come up with a totally different number on the top than you would have on the bottom. It does not put the number over itself. You'd have to have something like 12 over 4. Well, let's tip it over. Let's tip that one over, take off its identity, and find out what it really is. 12 would go over here. The line would split in half. The 4 would go over here. So this is your numerator. This is your denominator. Well, how many times does 4 go into 12? 3. There's our tool. That right there. So when you use a different tool, you would have to have a lot bigger number on top than you do the bottom. Whereas with number 1, it's so easy to use that you use the same number on the top as you do the bottom. 12 over 12. That would be our 12 setting. So you can't do this with any other number. This is the only tool that does that, and it's so amazing. And we use it a lot when we go to add fractions. So let's check it out. What if I wanted to add 1/4 plus 1/8? Well, how do I change fourths into eighths like I did here? I cut all these pieces, but remember I did it by multiplying the 1/4 times 1 and then adding it to the eighth. But wait a minute, how can you do that? Because that 1/4 times 1 is just going to be 1/4. We took our number 1 tool and we changed it to the 2 setting. So I'm going to take my number 1 tool, I'm going to take it and I'm going to change it to the number 2 setting. Are you ready? Yes. Ta-da! There's the number 2 setting. Remember, it's the number over itself. So now, what I'm going to do is I'm going to, and we'll erase that for later. When I change my fourth of a piece into eighths, not only do I change my denominator, but my numerator is going to change too. Look what I did. I cut my fourth piece into 2 separate pieces. And that's what's happening up here on the numerator. Now you don't just have 1/4 piece of pie, you have 2/8 piece of pie. It's the same amount of pie, but now there's 2 of them because they're in eighths instead of fourths. So whenever you change the denominator, the numerator is also going to change. You can't change the denominator without changing the numerator. That's why the number has to be put over itself, because when you change the denominator, you're going to change the numerator too. You can't cut this into eighths and still expect to have 1/8 of a piece. 1/8 would only be that big. Your piece that you marked out is this big. So in order to make it right, you would have to have 2/8. So when you use your number 1 tool to multiply times a fraction, you're changing not only the denominator but also the numerator, and we can see how that works because you marked out that 1 piece, but when we changed the denominator, it changed the numerator also. Now you have 2 pieces. They're smaller and it's the same amount of pie, but now there are 2 pieces that are smaller pieces. Okay? Now that I've changed my 1/4 to 2/8, now I can add it to the other eighth. So I take the 1/4 that is now 2/8 and add it to the 1/8. So 2/8 plus 1/8 is how many eighths? Well, we don't change the denominator because that stays the same. We're adding how many little pieces cut into this size do we have? Now we have 3, which would be one a little extra piece over here. So we have our 2 that we changed the 4th into, and now we're adding another 1/8. So now we have this much of the pie right there represented. 3 pieces that are cut into eighths. Okay? So that's exciting. This is what you can do with this amazing number 1 tool. Let's try another one with a different setting of the number 1 tool, okay? All right, let's try and say 1/3 plus 2/9. Well, I can't add these because 1/3 would be a pretty big piece of pie, whereas 1/9 piece of pie would be really small. Let's see, something like that. Not really good at that. Anyway, it'd be much smaller than the 1/3. So I'm going to have to change this 1/3 into 9ths. I'm going to have to cut each of these pieces into the setting that I need it. Well, what setting would I need when I multiply my 1/3 times 1 to get it into 9ths? How many times does 3 go into 9? What setting am I going to have to set my number 1 tool on? 3 goes into 9 3 times. So I'm going to have to set my number 1 tool to its 3 settings. So let me do that really quick. Okay, there we go. Now, my 1 has been set to the 3 setting, and now I'm going to multiply the denominator, which would be 3 times 3 equals 9. But remember, when you change it, I just changed it to 9. So each of these pieces that were 1/3 is going to be changed to a 9th. So now there's 9 pieces, and 3 of them make up that section that you had squared off as 1/3. So your 1/3 turned into 3/9. When we cut it up into 9ths, changing it from thirds, we also cut up and divided the numerator. So your numerator has to change when your denominator changes. Now that we have it cut into 9ths, we don't have just 1 anymore, because 1/9 would only be this much. And that's not how much you have marked off. You have this much marked off, so you've got 3 of these. You don't have just 1 anymore. You changed it from being just 1 big piece to 3 small pieces. That's what happens when you change the denominator. The numerator changes also. It always changes when you change the denominator, when you're using your 1 tool on an amazing setting. So now that we've changed this into 9ths, let's add that to the 9th that we already have. This one's already cut in 9ths, so we don't have to change it because that's where we want it. So we have 3/9, which is these 3 pieces right here, and now we have another 2/9. Here's a couple of those pieces right here. Well, how much would this be all added together? 3/9 plus 2/9 equals 5/9. They're still 9ths. You don't add those together. That's just showing you how big they are. The 5 is how many pieces you have all together. 3 of them plus 2 of them equals 5/9. Okay? So that's an exciting way that you can get from this denomination to that denomination by using your 1 tool at just the right setting.
Alright, so let's add this fraction together. 2/4 plus 1/8. Well, one of my pies is cut in 4ths, okay? The other pie is cut in 8ths. Let's see here. Alright, 2 of these would be like this here and this here. That's all this right here. That's how much pie I'm going to devour because I'm hungry. Then 1/8 would only be 1 of these here. Well, if I'm going to add them together, I need them the same size. Again, what tool do I get to use? That's right. In order to change this to this, because 4 does go into 8, so we can change this one into this one and just leave that one the way it is. But we're going to change this into 8ths. So I'm going to take my 2/4 times 1. But what setting do I need to change my 1 tool into to turn it into 8ths? 4 goes into 8 2 times. That's right. So I'm going to take my 1 tool and I'm going to change the setting to 2. 1, 2. Okay? There. I did it. It's on the 2 setting. Remember, it goes on top of itself. So now my numerator, or my denominator, can now be changed to 8. That's right where I want it. I had it right on the setting I needed. But the numerator, you see, changes also because I'm going to slice each of these pieces into 2. Now, how many of these pieces do I have? Now that they're sliced in half, I have 1, 2, 3, 4. Or 2 times 2 is 4. Now I have 4 eighths. Now they're both cut into eighths. And I have the same amount of pie that I had before when I had 2 of the 4 pieces. Over here, I had 2 of them. But now, that same amount ends up being 4 eighths. So I've changed this to this denomination. Now I can add it to that one. 4 eighths plus 1 eighth. Remember, we're just adding these eighths because they have to be the same size. So here's my 1 eighth plus the 4 I have over here. That's 5 eighths. So now there's 5 pieces of pie, and they're cut in the size of like if they were cut into eighths. 5 eighths piece of pie. Alright, and I used the number 1 tool on the precise setting that I needed it.
Are you in for a treat today? We have an amazing tool that will dice and slice and bake and cut, but not change the actual amount of pie you have, just change how many pieces that it's cut into. It's an amazing tool. What tool is it? It's the tool number 1. That's right. Anything times 1 is itself. It doesn't change the amount. It's still the same pie. 4 pieces cut into 4 pieces baked with the tool number 1 is going to be 4 pieces of pie. That's right. And it's so exciting. But what if I want my piece of pie cut smaller? Well, this tool is so amazing that you can actually change the settings on it. That's right. Put that checkbook away. We're going to find out what more this tool can do. Not only can it be multiplied by one number to keep it the exact same number, but it can change how many pieces of pie that your pie is cut into. Instead of being cut into 4s, I want my pie into 8s. Well, how do I do that with this amazing tool number 1? If I want to change this to an 8 and cut it into 8 pieces, then I'm going to have to change this 4 to an 8. How many times does 4 go into 8? It goes 2. So we're going to have to use our number 1 tool on the number 2 setting. So I'm going to change this number 1 to the 2 setting. So here we go. There it is. There's the 2 setting of my number 1. 4 is still going to be times 1, but it's going to be on the 2 setting. So 4 times 2 equals 8. There it is. And then the number of the numerator is going to change because when I now cut them into 8s, now how many pieces do I have? I have 2. But they're smaller, they're in 8s. It's the same amount, it's the same amount right there, but now I have 2 of those pieces because now they're cut into 8s instead of 4s. So look at that. I can change how many pieces that my pie is cut into by this amazing number 1 tool just by the setting I use. Let's do another one. Let's take our 4th piece of pie and use it to change it to 12s. Now my pieces are getting even smaller, but I still have the same number of pieces. So how would I get my 1/4 to change into 12s? I'm going to multiply it by that amazing number 1 tool again. But how many times does 4 go into 12? It goes in 3 times. So I'm going to set my number 1 tool on the number 3 setting. There it is, the number 3 setting, folks. So 4 times 3 equals 12. But remember, when you change the number of the denominator, you're also changing the number of the numerator. How many 12 pieces am I going to have? 1 times 3 is 3. Now I'm going to have 3 of these pieces because now they're in 12s. So now I have 3 12s. 1/4 is the same as 3 12ths because you're still taking 1/4 of the pie, but now it's in the form of 3 little 12th pieces, or before we had it as 2 little 8th pieces. Our pieces are getting cut smaller, but it's still the same amount because we're still only multiplying by that one tool. We're just changing the settings to however many we want. So yes, today folks, you can get that number one tool, and it's amazing because it puts the setting over itself. Any setting you set it to, I could set it to 15 over 15, I could set it to 20 over 20. It has so many settings you can't even count them all. What an amazing deal. Come and get your number one tool today. Change it into any setting you need to help your fractions become the fractions they need to be.